Hey everybody, welcome to week 2 of design programming. This week I'm going to take you through some of the details in how you can make different patterns with your code. Let's get into it. So until now what we've mostly been doing is giving the computer a series of specific instructions. Things that you tell the computer, okay, do this, draw a line, do this, draw a square, do this, draw a circle, and it carries them out in that order, top to bottom. But obviously, if you want to draw a lot of things, that gets quite onerous, and that's where conditional and loop statements come in. These are ways to control the flow of your code so that it only sometimes does some things, or that it does some things multiple times. Let's check out the details. Before we do though, I want to talk a little bit about Slack. Actually seeing you folks use Slack a ton, which is really great to see, but since I'd love to see even more activity on Slack, I wanted to go through a few details. You can post code directly in as a snippet. If you ask for a question on Slack or anywhere else, be as specific as you can and drop all of that code in. If you think there's a specific thing that you're having trouble with, drop us a specific snippet. Use 3 backticks and you can put code in and it'll format it as a code block, or you can create new message and sort of right click and drop a code snippet in from there. You'll get a much faster, much more accurate response. We won't have to mess around with, hey, can you post a link to the... It'll just go straight through. Just wanted to give you a bit of a structure of what we're going to go through in this week. We have a discussion of conditionals, which are how to get code to only execute some of the time. And then we're going to go through for loops, which is a way to do something multiple times. And then we're going to try and put them all together to do a bit of drawing. As I was saying, computers can make choices for us. We call these conditional statements. They execute conditionally, as is they execute dependent on the result of some condition. So have a look at this little example. If we're on this side of the screen versus this side of the screen, look at this, we're a robot with a computer, and on this side of the screen we're a camera with some popcorn. These, by the way, are P5.js sketches that are just running in the slides, so you can take a look at that if you want to right click inspect in the lecture slides, which you can get to from CCCs, and have a look at the code that we're using. Really, honestly, not that much. So the conditional statement, which is in this, and we'll go through some in a second, decides whether it'll draw everything this way or whether it'll draw everything that way based on the position of the mouse. Conditionals are tests. That's the way to think about them. Whenever the computer reaches that line of code, it checks, it tests the conditional and sees if it evaluates to true, as in yes, I'll do this, or false, as in I won't. Conditionals can be anything you want. They can be arbitrary expressions, and we'll talk a little bit about what an expression means, because they must eventually evaluate to true or false. You can put in as few things as you like or as many things as you like, but eventually it's going to just render down to yes, do the thing, or don't do the thing. In this case, we've got one where I click and it fires off this little function that counts down and plays scissors, paper, rock with me. So let's see, scissors, paper, rock. It was a draw. Let's do this again. Scissors, paper, rock. It was a draw. Okay, I'm pretty sure this isn't using my webcam. Scissors, paper, rock. Gotcha. Okay, I win. I'm better than the computer. We can move on. All right. All this does is it takes a on-clicked conditional. Is the mouse button clicked? All right, then we're going to do this. Is the mouse button not clicked? Then we're going to do something else, or in this case, nothing. You can again have a look at the code behind the sketch if you like, but this is just an example of how you use conditional statements to control what happens in the computer. This is the if statement. It's the most basic of the conditional statements, and I think it's one that you'll be able to get yourself going through the whole course. You go if something, some expression, something to test. So if x is greater than 5, then you execute this set of statements. So this is just a block, by the way. You may or may not have seen that already in your code. You see them around the draw and setup loops. All this means is all of these lines of code in between here and here should be executed together. So in this case, they're executed when this test is true, and you go else, and then you put another block of code. And all of the statements that occur down here are executed if this is not true. And that simply gives you a structure that breaks your code into two chunks, and only one of these chunks will run. You can have as little or as much in these as you want. You can have whole different programs in here, or you can just draw a triangle or a circle. So here's a specific example. Let x equal to n. If x is less than, those of you who remember this is the less than character. If x is less than 5, do this stuff, so draw a line. If x is not less than 5, so if this is not a true thing, then do this stuff as well. So what do you think happens here? If x is 10 to start with, x is not less than 5, this is more than 5, and so this code will draw this ellipse. You can copy this into your editor and check it out. We'll be doing similar things in the tutorial today. Or not today, if you're watching this beforehand. Expressions are, as I said, arbitrarily complicated if you need them to be. An expression can be as simple as a number. 5 is an expression. It evaluates to 5. 3 plus 3 is an expression. It evaluates to 6. An if statement, in particular, takes an expression that evaluates to a true or a false, which means that it needs to either be the word true or the word false, which are special phrases or words, I guess, reserved words in P5.js that evaluate to the concept of truth and the concepts of untruth. Or it needs to be a phrase involving a comparison, like an equals or a less than or a greater than. Because you can take any numeric thing, so 6 and 3 are components here in this one. 6 is greater than 3. Well, that's true. We know that's true. So that evaluates to true. Is 54 less than 50? No. No, it's not. You can do a lot more complicated things with expressions. They can have order of operations, or rather they do automatically have order of operations in them. You'll hopefully remember that from school, but we can go into more details on the mathematics of it later. But effectively, so this first executes 3 plus 2, so that's 5. Then it has resolved this sub-expression, so now that becomes 5 times negative 10. So 5 times negative 10 equates to negative 50. And so then that has resolved this second set of brackets. And now we just go left to right. Negative 50 plus 1, negative 49. So we're specifically interested for now for expressions that evaluate to true or false statements, because that is what an if statement will be able to work with. Funny story, if you give an if statement something that it doesn't evaluate to true or false, your code will sometimes still run and will do things you don't expect. So make sure you're giving it things that evaluate to a truth value. Specifically, we are interested in these comparative operators. Here are some specific examples of those relational operators. So is this greater than this? No. Is this less than this? Yes. And so on, just as I was saying. I've put a little bit more detail into these slides than I would normally use for a lecture, because honestly these slides exist as something that you should be able to go back to on their own without having to look at my face to refer to this content. Hopefully this is more digestible for you and more accessible than going directly to the P5 reference, which of course has as much stuff as you'll ever need on how expressions work and how if statements work. So I'm going to put these up as videos, but I'm also going to make sure that you can access the lecture slides from the top of the week's session in CCCs. So you've got a bunch of tutorial options there, a bunch of challenges that you can click on that are all sort of linked to each other, showing the order in which you can do them. But there's also going to be the lecture slides link at the top, along with a link to Slack as well. You should really go there. So now I want to talk a little bit about conditionals and how you can use them to do things. So if we have 3 is less than 5. Now you note there's no variables in here. This is always going to do exactly the same thing. So since 3 is always less than 5, this code, this ellipse, will always run, right? By the way, if you don't put an else at the bottom, it just doesn't have an else clause. So if this happens to not be true, nothing happens, which is fine. Sometimes you want that. if 3 is more than 5, we're going to do this rectangle. That code will never run because 3 is never going to be more than 5. Sometimes it makes sense to put absolute value expressions into your code, but in most cases you're going to want something in the expression to be a variable so that what happens is dependent on something else that's happening. There are some special variables automatically declared in P5.js that hold the value of stuff. It's just a convenience thing. So you can write code to create a variable whenever mouse button is pressed down. You do that using something called an event, and we'll handle those later. But you also can just know that mouse is pressed is a variable that's always defined, and it contains true if the mouse is currently being pressed and false if it's not. So let's have a look at what happens here. Look, if you put this this code here at the bottom into an editor, you'll see this code is run only when the mouse button is held down. It doesn't actually know which mouse button I'm pressing, by the way. That one's bound to back. Let's not do that. So, pretty simple. If this is true, when the draw loop executes, and we've talked a little bit about how there's a setup loop in P5.js which runs once at the beginning of your sketch, and then there's a draw loop that runs constantly as fast as the computer can draw your screen. And so that's what's used for animations, things that move around. In this case, it's just constantly running through that and saying, hey, is the mouse pressed? Hey, is the mouse pressed? Hey, oh, it is? Cool, I'm going to draw a circle. I just want to have a table here for you to reference. For those of you who may not be familiar with relational operators, greater than and less than are the absolute basics. You might remember in school that there are special characters for greater than, equal to, and less than or equal to. Instead of trying to hunt around on how to enter those special characters into your program, we find it easier to just use greater than, equal to, and less than, equal to indicate that you mean both. You might remember that we use the equals sign when creating variables. I'm saying, let x equals 10. That equals is actually a totally different mathematical concept than comparing something. Is x equal to 10 is a different thing to let x be equal to 10. We use the same word in English. That's because English is lazy. Mathematics is not lazy. We call this assignment. We call the other one assignment, let x equals 10, and this one equivalence. So if you put 5 equals 6, it'll say false. That's not true. 5 and 6 are not the same thing. If you put x equals 6, it will say, oh, is x currently 6? I think x is 10 right now. x10 is not 6. If you put a single equals, it will try to assign one to the other. And if you try and say assign 5 to 6, your computer will have a meltdown because you've just asked it to turn the number 5 into the number 6. And I'm pretty sure that there are several movies in which that's used to stop killer robots. So keep that one under your belt and don't get single equals mixed up with double equals. Just by the way, you're going to do that all the time. That's totally normal. We still muck it up too. You leave those sorts of errors. You never leave them behind. You still muck them up decades later. I left out a semicolon this morning when I was editing these slides. Don't think badly of yourself. Just try and remember. Okay, 1 equals assigns, 2 equals equates. And if you're ever interested in calculating the opposite of equals, as in is this not equal to something else, which happens a lot, then you're going to use the exclamation mark. Exclamation tends to be used to mean not in a lot of computing contexts. In some languages, you just get to write out the word not, but in JavaScript, we use exclamation equals. So these conditionals can be used to create interesting interaction. Have a look at this. If I move my mouse starts in the middle here, nothing happens. If I go to the left of this left-hand line, I get a square. If I go to the right of this right-hand line, I get a circle. So what's going on here? Let's have a look. If mouse x, which is another one of those convenience variables that just holds the x position of the mouse. For the record, in P5.js 00, you may have encountered this while drawing stuff last year. Hopefully it hasn't been that long. Last week. 00 is up here in the top left. So the x position is the number of pixels into the image from the left that the cursor is. So this distance here, and as I move it over here, it becomes this longer distance here. So mouse X is a number, and we're checking is that number less than or equal to width divided by 4. Width is another one of those convenience numbers. In this case, it holds the width of the drawing canvas. So if I exit full screen for a second, being clever enough to have removed any incriminating messages windows from the backdrop of my canvas here, and I can scale this window, and the width of the canvas changes because, of course, we're using responsive web components. And that width, please don't comment on the messiness of my desktop. That width is what's updating here. If we just put the total number of pixels that we want the canvas to be wide, when we resize the image, when you look at these slides on your phone or whatever, these would not work. Note that even though the screen is thinner now, I can still get those circles when I cross the line, which means that not only is the mouse X variable updating in the way that I want, as in it's moving with the mouse, but the width variable is updating behind the scenes as well. Just for the record, it's this sort of stuff that's the reason why we use P5. It's so much more convenient to just be able to know how wide your sketch is at any point in time, or just know where the mouse is. You don't have to do anything special. You don't have to write any code for that. It's all just taken care of behind the scenes. But let's look what happens. If the mouse X is less than or equal to a quarter of the width of the screen, then we're going to draw a rectangle. And if the mouse X is greater than or equal to, and this one's a little tricky, width minus width on 4. So what's that? You take the total width and you remove a quarter of it, so you end up with 3/4 of the width of the screen. Then we're going to do this ellipse. What's not shown in this little code snippet is the thing that draws the red lines. Obviously, those red lines are being drawn at width on 4 and at 3 width on 4, or width minus width on 4, whichever way you want to think about it over here. Again, if you want to right-click, inspect this, you can see the whole of the sketch code. It's just included with this file. You should be able to load it directly in your browser and feel like you're a bit of a hacker today, which is always fun. Just for the record, you don't have to use numbers. You can... This is a little bit, this is stuff that we'll cover in a couple of weeks, but as in what does it mean to be having function key pressed, and why is that super special, and it triggers something when keys are pressed. But if you put this into your code, just copy paste it in for now. I'll tell you what it does is this code gets run by P5 anytime a key is pressed on the keyboard. And what this is doing is saying if key, which is one of those special variables is behind the scenes, the currently pressed key, or rather the last pressed key, is equal to, and again, that's that equivalence, A, then draw an ellipse. If you drop this code into an editor and then all of it, and then press A, you will get a circle whilst you're pressing A, and it'll disappear when you stop. It's just a simple conditional. It is, in that case, relying on the existence of this special function key pressed that you can write, but that'll be less magical in a couple of weeks' time once we get to events. So you can have compound operations, which rely on what's called Boolean logic, which is just logic with truth values. So you can think of the English words and, or, and not here, and then we have special symbols for each of those. Logical and just means that X and Y means that both X and Y have to be true. Logical or just means one or the other has to be true. Logical or does also include both, so you should think of it as at least one of these things has to be true. And not means just the opposite of true. So not false equals true. Seeing some of those are written out here. This is a little thing we call a truth table that might help you to remember how some of these things work. But with these comparators, we can put together arbitrary conditions that collapse multiple different things down to a single true or false value and allow us to make a decision based on that thing. So let's think of a simple way to do that. Well, this circle only appears if I'm in the middle of the screen. So that's the opposite of the previous examples where I had to be over here or had to be over here. And this is handled with a single condition. You'll often see something like this. You've got an if statement that has a very simple execution. So all it does is draw a circle, middle of the screen. But it has a complicated condition. Let's kind of break this down and see if we can figure out what's happening. Well, the first thing we have is the AND in the middle, which means that everything to the left of the AND is an expression of its own, and everything to the right of the AND is another expression. And we know with that AND there, they both have to be true, or it will all be false and do nothing. So the left one, if mouse X, remember, that's a special thing that holds where we are in the X position on the screen, so it's how far across the canvas are we, is greater than or equal to width on 4, well, then we're going to say, yep, that left expression is true. This equates to true anywhere over on this side of the screen. So that's actually still true over here, right? But this other one has to be true as well, and this is mouse is less than or equal to this thing, which we know equates to a quarter of the width, that's the same as this one over here, times 3. So this is the same way of getting what we had before. Sorry, this is another way of getting the same thing that we had before, 3/4 of the width. So the mouse X position must be greater than 1/4 of the screen and less than 3/4 of the screen. So this thing is only true in the middle. Seems pretty straightforward, I hope, but you can use these to make arbitrarily complicated bits of cool stuff. Same thing can happen for non-numeric data. In this case, if the key pressed is equal to A, or that double pipe is the OR operator, which lets you compound two things together and only one of them has to be true, or the key pressed is capital A, then we're going to do this thing. So you can run that, and even if you've got caps lock on, you'll get the same behavior when you press the A key. So I'm going to split this up into multiple videos. That was the basics of conditionals. That is code that only runs when an expression is true. I hope that you can use that to write more and more complex, cool stuff. I'll see you in the next video when we're going to talk about running stuff multiple times without having to write the code out multiple times.